So today we're going to talk about network at our hackerspace. Now a little bit about the background and context of this talk. Back in 2017 we wanted to build a network infrastructure for our 350 square meter hackerspace. We had people of different backgrounds. They wanted to have internet connectivity for laptops, smartphones, IoT gadgets, 3D printers, PCs, NAS boxes. And what's a bit unique about us, we had lots of people who wanted to host their servers. Many of us wanted to learn more about networking in general. And what is unique about our hackerspace is that we wanted the network topology of the hackerspace to be freely discussable with outside parties, which is usually not the case for most corporate networks. And of course, we wanted to do all of this dirt cheap. So back in 2017, when I started the place with a bunch of students, I pretty much called up all my friends and acquaintances from different companies, and I pretty much asked them what could they donate us. So we ended up having a bunch of DDR3 era hardware. We got a bunch of Dell R710 servers and a bunch of Hewlett-Packard 7th generation Blade servers. We also got a bunch of Cisco switches and routers. Some of them had 10 gigabit capabilities, some of them didn't. And we also had a dozen COMFAST access points. And at some point we also received, I believe it was about 100 SFP and SFP Plus modules of different vendors. So when we started the place, we repurposed one of the rooms as server rooms. We had 5 racks for servers there, and the 6th rack was dedicated for networking equipment. We patched 1 gigabit copper links from every server rack to this networking rack, and on the bottom you can see the 4 Cisco switches we used in the beginning. The remaining rooms were connected via 10 gigabit links. The cool thing about Cisco 3750 switches is that each one of them had 2 10 gigabit links. So we pretty much wired up the remaining rooms via optical links, and we had essentially 10 gigabit backbone already back then. So all of this was basically donated hardware except the stacking cables. So all of the 4 switches, they were interconnected via stacking cables, which essentially turned this into a giant big switch. Now the problem with this hardware was that it was manufactured back in 2009, so it was very old by 2017 standards already, and occasionally it would get stuck during a cold reboot. So eventually we had to unplug these switches, which we did already in 2020. Now, the problem with the fast networking is that once you get taste of it, you want to have more. This is just to recap what we learned over the years. What kind of options do you have to connect equipment for fast networks? So for a small home lab and also for in-rack wiring, you would use SFP Plus direct attached copper cables. So these DAC cables pretty much omit conversion to any other on-wire standard, which gives you the benefit of saving some power and not having to deal with optical links at all. Now, QSFP Plus modules basically bundle 4 of SFP Plus links, which gives you in total of 40 gigabits of throughput. Now, the problem with DAC cables is that they're inherently limited in distance, so you would get something like 3-meter cables, and that's about it. If you want to interconnect racks in a server room, you would probably go with multimode modules. These are the ones which use the green optical cables, which would be accompanied by a suitable SFP Plus optical module. Now the optical module pretty much just converts the electrical signals into light. For multimode, it uses LEDs. Now, if you want to go beyond a couple hundred meters, then multimode doesn't cut it. You would have to switch to single mode wiring. Single mode wires are the yellow ones, usually. And the difference between multimode and single mode is that single mode uses lasers instead of LEDs. And with single mode, you could achieve links of tens of kilometers. Now, the regular copper Ethernet cabling that you're familiar with from home networks I don't know anyone who does 10 gigabit networking over that. The problem with 10 gigabit networking over Ethernet is that it draws quite a bit power. So with some switches, you might end up in a funny situation where you cannot use all of the ports because of the heat dissipated by the Ethernet modules when they run at 10 gigabits. So in reality, for really fast networking, you probably have to switch to optical one way or another. Now, as I mentioned in the beginning, we got a bunch of Mellanox and Avago SFP modules. The problem is that the switch vendors do discriminate SFP modules. And for instance, if you have a Cisco switch, you cannot probably usually plug in arbitrary SFP modules. You would have to get SFP modules from Cisco. With servers, it's kind of easier because usually the network cards do not care what kind of SFP modules you plug in. So some of the network cards we do use in our server room include Chelsea OT320, Mellanox CX312, and of course Intel X520 and X710. So what did we do with 100 SFP modules from random vendors? Well, we obviously bought a switch that doesn't care what you plug in. And that is the case for MikroTik at the moment. They're a bit of a small switch and router vendor from Latvia. So we got 2 cloud router switches from MikroTik. They're the ones on the top here. Each one has 24 10 gigabit links. You can load it with random SFP plus modules essentially. And the switches are interconnected as well. We have there 2 QSFP plus duct cables. And those duct cables are bonded together so you get 80 gigabit connectivity between the switches. Now the reason why we have 2 switches in the first place is to provide some redundancy. As all of the traffic goes through these switches, we want to be able to, for instance, reboot one of the switches or perform a firmware upgrade on one of the switches without causing a blackout in our hackerspace. And this is exactly what is achieved by using 2 switches in a redundant configuration. You can see all of the green optical links here. All of them, they go to different servers in the same server room. And the yellow ones are spread out over the building in different rooms where we have more switches which connect wireless access points and computers over wired network. So on the bottom here we've got 3 more switches. The 2 on the bottom are simply providing, again, highly available copper links to the servers. And the third one connects the management interfaces of all of the servers. So for instance, when somebody configures a network interface on their servers, if they mess up something, they could still connect to the servers over the management switch. Now, in another rack, we've got also a router, which is a repurposed Dell R710. The R710 runs Routeros as well. So the cool thing about MikroTik is that they actually do provide the disk image of their software, and you could load it to a pretty much random PC and run it there. The cool thing is that it also supports the Intel X520 network cards, so you can also hook up 10 gigabit connectivity to your homemade router, basically. So this is how our network looks like pretty much at the moment. So the core switches are here. Each one of them is connected to a different internet service provider. And both core switches are connected to the router as well. We're juggling an idea to add a redundant router, but we haven't done it yet. And everything that is connected to the core switches is connected in a highly available fashion. So you've got dual links going to every room, every file server, every tenant server, every Hewlett-Packard Blade enclosure switch, and the other switches in the networking rack. There are 1 gigabit copper links in every room. We've got access points connected to them. Tenant devices, or in our case our hackerspace members, can connect their wireless devices over these access points to internet. And they're also provided with some wall sockets so they can hook up their 3D printers and desktops and whatnot. Our Hackespace members are also welcome to host their own servers with us. So if they do have 10 gigabit connectivity, they're welcome to connect it with multi-mode cables. We do run some servers ourselves, so they're also connected over 10 gigabit links. There are loads of devices connected to the Hewlett-Packard blade enclosures. Unfortunately, the blade enclosure switches that we have at the moment are a little bit limited, so we get only 2 gigabit links to every blade server. We've got 3 blade servers running a hypervisor. We run Proxmox to host our member virtual machines. And Proxmox gets its storage over these 2 gigabit links and over the 10 gigabit links that go to the file server. We run a bunch of services in containers as well. And our members are welcome to come and rent a blade server as well. And for everything else, we've got the highly available CRS328 switches in the server room. And that's actually how most of the servers are connected at the moment. We recently added high availability for these connections as well. So this is the network, how it's implemented at our Hackespace. But the thing is that many companies have networks very similar to this one. So some of the remaining issues with our network setup is that the 2 core switches that we have, their configuration is essentially duplicated. But we don't have any centrally applied configuration in place. We just recently started collecting the switch and router configurations into a Git repository so we can at least track changes. The other issue is that we are still running RouterOS 6. The RouterOS 7 is in beta, and RouterOS 6 doesn't support multi-chassis link aggregation. And this pretty much implies all of the 10 gigabit links are active passive bonds, which means that even though you have 2 10 gigabit links available, only one of them is utilized at a time. And as mentioned, right now we don't have fast network connectivity in the Hewlett-Packard blades. We're hoping to change that soon, but for now we're stuck with LACP bonded 2 gigabit links per blade. And one of the options is the SFP Plus pass-through module. And the remaining issue with the Hewlett-Packard blades is that we're stuck with LACP bonded links, so that maxes out at 2 gigabits. We can't really have a 10 gigabit connectivity at the moment to the blade. Fortunately, the link from the switch blade to our core switches is 10 gigabits, but we're hoping to get a 10 gigabit connectivity to every blade soon as well. If you want to host stuff with us, become a member, obviously. Outsiders are welcome to hang out on our Slack channels as well. Alternatively, just drop us a line, what is it that you need, and we'll see what we can do. So, outsiders are welcome on our Slack channels as well. You can just come and chat. In any case, reach out to info@kspace.ee. Note that our infrastructure is offered on a best effort basis. So far, we've done pretty well from uptime perspective. We nowadays have an intern hired to deal with on-prem issues, but do not put mission-critical stuff there, obviously. Most of the stuff that we run there are just educational and hobby projects. We do have a couple companies who host their development servers there as well. I'd like to thank Christian Kuusk and Erkki Aas for network configuration. Honestly, I haven't touched the switches at all. It's pretty much their show. I'd like to also thank Song Meo for building the monitoring for the networking stack. And I would like to thank Royal Surf for providing us with optical cabling and also welding the optical patch panels. And of course, I would like to thank all of the hardware donors and numerous other people who helped out with, carrying racks to 5th floor because we don't have an elevator. And I would like to thank Startup Estonia and Credex for supporting creation of these videos. We're planning to make loads of more. We've got one coming up on 10 gigabit connectivity because there's lots to discuss there. There's going to be talk about virtual LANs and how we have implemented those. And there's going to be another one on the high availability aspects of our network.